Hey there, and welcome back to DevDive. In today's episode, we're gonna have an introduction to Maven. And the aim of this video is to provide a solid understanding of the why, so diving in the code later will be easier and it will have more sense for you. So without further ado, let's get started. According to Maven official documentation, Apache Maven is a software project management and comprehension tool. Based on the concept of project model POM, Maven can manage a project's build, reporting documentation from a central piece of information. That's a clear explanation of what actually Maven does. It's a really interesting tool because using a file, a pom.xml, it can keep track of our dependencies and generate our builds and do all the heavy work for us. And in order to get a better understanding of what it does, we should get familiarized with the principle of convention over configuration. Convention over configuration is a simple concept. Systems, libraries, and frameworks should assume reasonable defaults without requiring complex configuration. Of course, it can be overridden, but the main idea is to reduce the number of decisions developers need to make, gaining simplicity without losing flexibility. In the next slide, we're gonna see concrete usage of this concept in Java frameworks. As you can see, Spring Boot uses an embedded server for deployment. And the interesting part is that when we as developers use Spring Boot, it feels like there is no Tomcat server at all. And to get this transparency, a lot of default configurations were already made for us, like thread pooling, security, context path, session timeout. But we can still override this configuration in application properties. I'm gonna stop here, but if you guys want some Spring Boot series, leave it in the comment section. GPA also does the same using annotations. It will do all the heavy work for us, getting the table name from the class and columns from field, writing the SQL query to create the table, adding constraints, and that's the power of frameworks, and that way we can focus on the business logic instead of configuring the tools we're using. Maven incorporates the concept of convention over configuration by providing sensible default behaviors for projects. Without customization, source code is assumed to be in base directory /source/main/java, and resources are assumed to be in the base directory /source/main/resources. Tests are also assumed to be in the test folder, and a project is assumed to produce a jar that will be used to run the application in the server. And Maven assumes that you want to compile bytecode to base directory /target/classes and then create a distributable jar file in the base directory /target. It seems trivial, but trust me, in other solutions like Ant, builds have to define the location of these directory in every subproject. So that's the power of Maven. Maven adoption of convention over configuration goes further than just simple directory location. Maven's core plugins apply a common set of conventions for compiling code, running tests, packaging application, deploying app, generating websites, and many other processes. And if you follow the convention, Maven will require almost zero effort. Just you put your source in the correct directory and Maven will take care of the rest. So now that we're familiarized with Maven and we know why would we use such a tool, let's talk about the age or the era before Maven, because developers and build engineers faced many issues during the process of building system. One of them was the custom build systems, because each project had its own build system, meaning that there wasn't a standardized way to build software, and this often involved custom scripts and configurations that were unique to each project. And this led to a high learning curve for developers because they had to spend time learning how to use each project specific build system, and this was time consuming and inefficient as developers couldn't seamlessly transition between projects without first understanding the custom build procedures. Another issue was having a dedicated build engineers because a project need a dedicated personnel that to manage these custom build system, and their role was to ensure that the project could be built correctly, dealing with the issues of this particular build environment. For example, integration of new tools, because when new tools or frameworks such as a static analysis tool or a unit testing framework were introduced, integrating them into the existing systems was a challenge. Each project had to figure out how to incorporate these tools into their unique setup, leading to further inefficiencies. And the lack of standardization led to endless debate about the best tools and methods for building projects. This environment was inefficient as much time as wasted on discussions and managing custom built environment instead of focusing on actual development. With the introduction of Maven, we effectively eliminated many challenges. Maven handles dependency management by automatically downloading the necessary jar files for us. This automation simplifies the process, ensuring that all required dependencies are consistently available. Moreover, the reuse of camel logic through Maven plugins have been revolutionary. Instead of dedicating significant time and effort to creating and maintaining project build systems, we can now simply specify the appropriate plugins. These plugins handle the build processes, streamlining our workflow and enhancing productivity. Don't be that amazed with Maven because it's a pretty dumb tool. Parsing an XML file and keep track of a life cycle is all it can do, but all the responsibility is delegated to plugins. All of the actions are happening using goals like compiling, packaging, testing our project. We can also create our own plugins. In the next slide, we'll see some examples of these plugins are what they can do. So as you can see, these are some common plugins used in Maven. For example, Maven Surefire plugin, which is a plugin responsible for running unit tests using JUnit. So basically, it will look for tests in the base directory /source/test, and it will execute all the available tests. The Maven compiler plugin is a plugin responsible for compiling the project source code, and it will put the bytecode in base directory /source/target/classes. And the Maven jar plugin is responsible for packaging our app into the base directory /source/target. So it's really interesting to see how using and adding a code in our pom.xml can add these features in our build process. At the end of this video, I wanted to show you the conceptual model of a project, or what we call POM, which is an XML file where all the magic happens. For example, managing dependencies, remote repositories, using plugins. But I'm not gonna go deeper because, as I said at the beginning of this video, the aim was to introduce you to Maven and why would we use it in enterprise dedicated projects. Don't worry, in the next videos we'll cover all the details like configuration, plugins, we'll even create our own plugins. So just stay tuned for the upcoming videos. Thank you guys for watching. I hope that the content of this video was helpful. Take care and I will see you in the next one.